Hi friend, today we will study about de Broglie equations which was about to approximate given in 1925 or 26. De Broglie equations, we can say it is nothing but then a wave equations. According to de Broglie, if a particle behaves like a wave, on the other hand wave behaves like a particles, then Broglie put up his idea in terms of a wave which is called as a matter wave. We know that energy of each particle which has mass m, the total energy which may be internal energy E equal to mc square is equation number 1 is as given by Einstein in his relativistic theory. On the other hand, in 19th century, when Max Planck put up a new idea that energy can be emitted or absorbed in terms of only and only quanta bundle, then we can say that energy of a photon E equal to h nu, where nu equal to frequency of photon, h equal to Planck constant. Suppose that this is a photon which is made of frequency nu, then the energy of this photon E equal to h nu. Whatever the value of nu we can multiply with h and it will be the total energy of this photon. On the other hand, the E equal to mc square, suppose that this is a mass particle and it has its mass m, then the total energy which contain this particle equal to mc square. De Broglie take up these two hypotheses and convert in a new idea. He says that if a particle has energy, on the other hand, the energy shows like a particle or packet nature, so why should it not be possible that there may be a relation between them, and the relations is known as the de Broglie equations. By equation first and second, we will have mc square equal to h nu mc into c equal to h nu mass into c is the speed of light, as we know that the moment of p equal to m into v. In the case of photon where v equal to c, the this term equal to m into c, this is the nothing but that the momentum of a photon. Then we will put this value here, p into c equal to h nu. Here p equal to h nu over c. We know that nu and lambda always equal to c. If we are interested to find out the value over nu over c, by multiplying here we will have nu over c equal to 1 over lambda. Then we can put here 1 upon lambda, the p equal to h into 1 upon lambda, lambda equal to h upon p. Here lambda, sorry, here lambda is wavelength of de Broglie wave, which is the matter wave. We can say that if a matter particles which is moving in any directions, there must be a wave, matter wave, which is associated with this particle, and it will have a frequency and a wavelength. The wavelength is here, this is equal to lambda, and this is known as the matter wave, which is always obey and moves along and same speed as particles moves. So we can say that its picture look like this. electrons and proton, each and every particle which is moving in any directions, there should be a de Broglie wave which is associated with this particle and move in same direction with same speed. This is the called de Broglie wave. And wavelength of this wave is lambda equal to h upon p, p equal to momentum of particle, h equal to constant. In next lecture, we will find out the relations between h and e and lambda if a particle is moving in much higher speed approximate to c. In this case, we are just put this idea that velocity of particle is much lesser than c, speed of light. In next video we will find that what will be change in the behavior of lambda a particle velocity v approximate equal to c or v approximate at c. Here p we can change in term of energy, as we know that p equal to mv or mc is momenta. We know that E equal to p square upon 2m, p equal to under root 2me. Now substitute this value at here, we will have lambda equal to h upon 2me, where m is the mass of particle, E equal to total energy of particle which is moving, h is a constant, and lambda equal to de Broglie wavelength of matter wave or de Broglie wave which is associated with that particles. Thank you very much.